For ages, people have wondered what things might be like in other universes. Now, with the James Webb Space Telescope, the best tool we've ever made for looking at space, we might finally get some answers. When looking at Proxima Centauri, which is our closest star system at only 4 light-years away, scientists saw some weird stuff happening on one of its planets, Proxima b. These weird lights, which seem man-made, have really caught the attention of scientists. What are they? Could they mean there are smart aliens living there? Let's check out what the James Webb Space Telescope found. It might totally change what we think we know. Right now, as far as we know, life only exists on Earth. Since the beginning, humans have wondered if there's life out there. To find out, Jill Tarter and Thomas Pearson, 2 American scientists, started the Search for Extraterrestrial Intelligence (SETI) program in 1984. The plan is to pick up radio signals from space. Because radio waves can travel super far, there's a better chance they'll be picked up by the 42 radio dishes at the Allen Telescope Array in California. So far, no confirmed alien messages have been found. But getting the James Webb Space Telescope up and running has given the search for planets around other stars a boost. It's the most powerful telescope ever, sitting almost 1 million miles from Earth and packed with super-sensitive gear, so it's ready to make some big finds. Not long ago, we hadn't found any planets outside our solar system. Now, over 4,000 exoplanets have been spotted orbiting stars all over our galaxy. NASA thinks there could be millions more out there. One way to spot signs of aliens is by looking for alien plant life. When the Galileo spacecraft went to Jupiter, it looked back at Earth and saw a clear sign of plant life, the vegetation red edge. It's a light signature made of red and infrared light that plants reflect. A planet covered in jungle, like Earth, would have a strong red edge signal that's easy to spot. The James Webb Space Telescope is made to measure the red edge of faraway Earth-like planets in the habitable zones of other stars. This could tell us a lot about what's happening under a planet's atmosphere. When light from a star goes through a planet's atmosphere, the telescope can break it down to see which colors are missing. Each missing color shows that something in the atmosphere is absorbing that light, giving us a unique fingerprint. This may help scientists figure out what a planet's atmosphere is made of and if it could support life. For example, if a planet the size of Earth has oxygen, nitrogen, and carbon dioxide, life might be possible. Plus, finding rare stuff like chlorofluorocarbons, CFCs, which are chemicals used in refrigerators and cleaners, could mean there's a technological civilization. If alien scientists were looking at Earth, our CFC emissions would be a dead giveaway that we're an advanced society. But life on other planets might be very different from what we know. Some life forms might be able to live in crazy conditions. These extremophiles, creatures that can survive where others can't, could look totally alien. These tiny guys can handle crazy heat, up to 250 degrees Fahrenheit, or super acidic conditions. Since Earth-like conditions are better for life, it makes sense to look for planets with mild climates and liquid water first. The best candidates are planets with temperatures that allow water to stay liquid and that orbit stable stars. Our Sun is a yellow G-type star, which has a pretty good lifespan. Red dwarfs, on the other hand, are more common and burn cooler and dimmer than the Sun, so they last way longer, giving life plenty of time to evolve. One example is TRAPPIST-1, about 40 light-years from Earth, which the James Webb Space Telescope looked at first. It has 7 rocky planets about the size of Earth. 3 of them are in the habitable zone and might have water on the surface. Even though the TRAPPIST-1 star is smaller and cooler than our Sun, it gives off similar light, and because the planets are so close, they're the best bet for finding artificial lights outside our solar system. Another good target is Proxima Centauri, a red dwarf only 4.25 light-years away. Since it doesn't give off as much light as the Sun, any planet that could support life would have to orbit super close. In August 2016, astronomers found Proxima b, a rocky planet about 1.3 times the size of Earth, in the habitable zone of Proxima Centauri. This Goldilocks zone has just the right amount of starlight to keep water liquid. However, Proxima b might be a dry, airless rock. Its tight orbit, only 4.6 million miles from its star, means it gets blasted by solar winds that could strip away its atmosphere. Still, Proxima b gets enough light to stay warm and maybe keep water liquid. Because it's so close, it's probably tidally locked, meaning one side always faces the star, like our moon with Earth. Proxima Centauri, which is about 18% of the Sun's mass, only gives off 5% of its brightness. The surface of Proxima b might seem like a scorched wasteland, but if it has an atmosphere to trap heat, water could still be there. Since Proxima b only gets about 65% of the Sun's energy that Earth does, it might not be super comfy for life. Still, it's a planet worth checking out. The tidal locking could cause huge temperature differences between the sunny and dark sides. Plus, the planet gets hit with almost 3 times as much harmful radiation, like X-rays and ultraviolet rays, because it's so close to Proxima Centauri. Unless Proxima b has a magnetic field like Earth, life would have a tough time. Even so, some things could make Proxima b more inviting than it seems. Some models show that atmospheres on tidally locked planets can collapse as gases freeze on the cold, dark side. On Earth, volcanoes help put gases back into the atmosphere, and a strong magnetic field helps keep them there. Since we don't know much about Proxima b's volcanoes or magnetic field, we can't say for sure if it has an atmosphere. But, if it does, that means there could be oceans, which raises the chance of finding life. If we're lucky, Proxima b might have advanced energy stuff on its sunny side, like solar power plants, to light and heat the dark side, making it livable. The find of Proxima b has started a race to see if it passes in front of its star as seen from Earth. If it does, scientists could figure out the planet's size and mass, calculate its density, and see if it's rocky, giving us clues about what it's made of. If this happens, light from the star would go through Proxima b's atmosphere. There's only a 1.5% chance that Proxima b's orbit lines up perfectly with our view. The fact that Proxima Centauri is unstable makes things even harder. Astronomer David Kipping from Columbia University said that the star is superactive, and solar flares force rocky planets to soak up radiation and send it back as infrared light. Rocky planets give off a special kind of infrared radiation, especially ones orbiting stars like Proxima Centauri. Luckily, the James Webb Space Telescope is designed to spot infrared light. Finding Proxima b's infrared profile is really important for knowing if it has an atmosphere. The James Webb Space Telescope is way better than the Hubble telescope at seeing infrared light, so it can spot artificial lights, even if they're as faint as Earth's. If these lights are focused in a narrow range of colors, separate from the star's light, it could mean there's a technological civilization. It's possible that Proxima b's sunny side is covered in solar panels reflecting starlight. Since the planet is locked with its star, it always has a day and night side, which causes big climate differences. If Proxima b doesn't have an atmosphere, its sunny side would release all the energy it absorbs as black body radiation, while its night side would stay frozen. But, if the temperature difference isn't that bad, it could mean there's an atmosphere. The James Webb Space Telescope only needs 11.2 Earth days to gather enough data to maybe spot artificial lights on Proxima b's dark side, signals that could point to smart life beyond our solar system. Right now, it looks like Proxima b might be hiding amazing secrets. Maybe its sunny side makes tons of solar energy, powering a thriving and advanced civilization. Finding artificial light would be huge, but scientists are being careful. These finds could mean intelligence, but they could also be from natural stuff. The James Webb Space Telescope's tools are still new, and researchers are working on their techniques. These lights might turn out to be volcanic reflections, lightning storms, or weird atmospheric effects that just look like artificial light. It's really important for astronomers to double-check their data and stay cautious. The James Webb Space Telescope will keep watching Proxima b, along with other promising exoplanets, to learn more about their atmospheres and surfaces. If artificial lighting is really found, it would start years of extra research to confirm where it's coming from. If it does come from smart life, it will be one of humanity's biggest scientific wins. The interest in Proxima b and other similar planets goes beyond science. It gets into big questions about what makes humans special. Discovering alien civilizations would make us rethink our place in the universe. It could start a time of global teamwork, as the find of alien life would bring us together in amazement and shared purpose. It would also show how important it is to keep exploring space and making technologies that let us go deeper into the universe. For now, the search for city lights on Proxima b is still a cool thought, one that might soon answer the old question of whether we're alone. As the James Webb Space Telescope sends back more data, the chance of finding smart life seems more real, bringing us closer to one of science's biggest answers. If Proxima b really has a sophisticated society, this find could start a time of exploration and talking to other stars. As we push the limits of what we know, the next generation of scientists, astronomers, and pioneers might be the ones to prove the impossible, that life, in all its different forms, is way more common in the universe than we ever thought.